Welcome to the introduction and overview of APTI 419B, Preparation of Fine Particle Emission Inventories. This is the fourth of several modules that introduce the APTI Classroom Course 419B. This module introduces the Non-Road Emissions Inventory. This model overviews the following non-road emission categories: engine emissions for categories contained in EPA's non-road model, aircraft, commercial marine vessels, and locomotive emissions. The non-road emissions estimation model contains most types of non-road engines. They are differentiated by equipment type. It can produce inventories for past, present, and future years, and it's a standalone. No user data is necessary. The following equipment categories are contained in non-road: airport ground support, agriculture, construction, industrial, commercial, residential commercial, lawn and garden, logging, recreational marine vessels, recreational equipment, oil field equipment, underground mining, and railroad maintenance equipment. Of those categories, several are key PM 2.5, construction, agricultural, and industrial, particularly the diesel part, and two gasoline-fueled categories, lawn and garden and recreational marine. PM 2.5 and PM 10 primary are estimated in the non-road model. Also, carbon monoxide, NOx, VOC, sulfur dioxide, and carbon dioxide. Let's discuss geographic and temporal allocation in non-road. The national equipment populations are allocated to county level using surrogate indicators that correlate with non-road activity for specific equipment types. An example would be using cropland to allocate agricultural emissions. Non-road contains monthly activity profiles for each equipment category. These are specific to 10 geographic regions. Inputs to non-road can be improved with local knowledge. Local fuel characteristics and ambient temperatures are usually available. Local activity inputs may be available to replace non-road model default activity data, and local geographic allocation indicators and temporal profiles can be used. Aircraft emissions are considered a part of the non-road mobile source inventory. The categories included in the NEI are commercial aircraft, general aviation, and air taxis. The NEI aircraft inventory only includes emissions at airports and landing takeoffs below 3,000 foot altitude. No in-flight emissions between airports are included, except in-flight emissions of lead from general aviation. The estimates are top-down. They're allocated to airports from national estimates of fuel consumption. Commercial aircraft is the largest aircraft emissions category. Landing and takeoff statistics are obtained from the FAA. Airports are located by latitude, longitude, so that they can be studied and modeled as point sources. Commercial aircraft emissions are estimated using the FAA's Emissions and Dispersion Modeling System, or the EDMS. These include aircraft taxis, landings, and takeoffs up to 3,000 foot altitude, as well as aircraft ground support equipment and auxiliary power units. Let's talk about general aviation, air taxi, and military. National emissions for general aviation and air taxis are created top-down. They're allocated to airports from national estimates, but the data come from different FAA reports and are not broken down by aircraft type. EPA is not currently estimating emissions for military aircraft. The following categories of commercial marine vessels are in the NEI: diesel-powered vessels and emissions from vessels fueled by residual fuel oil. They're separated into import and underway emissions. Diesel commercial marine vessel emissions are top-down, where the inventories are estimated from national level data. These emissions are then apportioned between port and underway. 75 to 80% of all diesel fuel is consumed in port, according to the EPA. Port emissions from diesel commercial marine vessels are allocated to the 150 largest ports using port traffic data. These data are from the Waterborne Commerce of the U.S. publication. Since all national emissions are allocated into only the 150 largest ports, these ports data are somewhat inflated. Port and underway emissions are spatially located in GIS shapefiles. This way, they can be easily allocated to multiple counties and grids by using GIS tools. Residual fuel vessel emissions are compiled for 117 ports. Emissions are split between the port and underway depending on the operating mode. Hoteling and maneuvering emissions are assigned to port, but emissions in reduced speed zones and cruising are assigned to underway. As with diesel vessel emissions, these emissions are spatially located using GIS shapefiles. The NEI's CMV emission estimates can be improved with local input. Port emissions can be allocated to ports other than the 150 largest. Vessel activity data can be obtained at the local or state level from Department of Transportation or port authorities, including the number, size, and fuel consumption by vessel category and the number of hours by operational mode. Locomotives are also included in this inventory. The locomotive categories include diesel line haul, classes 1, 2, and 3, diesel rail locomotives, and diesel passenger or Amtrak and diesel commuter trains. Class 1 line haul locomotives account for about 80% of the fuel consumed by all rail operations. Emissions are estimated by the equation emissions equals fuel consumed times an emission factor. The Eastern Regional Technical Advisory Committee, or ERTAC, developed locomotive emission estimates for the 2008 NEI. Let's discuss the general methodology for locomotive emissions. First, we'll need fuel consumption. It's usually expressed in gallons. It's calculated by dividing the traffic density in gross ton miles by a system-wide fuel consumption index in gross ton miles per gallon. Then we apply an emission factor expressed in pounds of PM10 or pounds of PM2.5 per 1,000 gallons of fuel. These factors are year-specific because the locomotive regulatory requirements are changing. Emissions are estimated for both line haul and rail yards. The inventory produced by ERTAC for 2008 offered the following enhancements. Link-level activity was obtained from national rail companies. This improved railroad-specific fuel consumption. GIS shapefiles were used to geolocate the links so the inventory could be easily allocated to grids or counties. ERTAC also included Class 2 and Class 3 line hauls and rail yards in their inventory. Now let's summarize the Nonroad overview module. The Nonroad model offers a consistent approach for multiple source category emission estimation. Users may rely on defaults built into Nonroad so they can avoid local data collection. Commercial aircraft emission estimates are done at the airport level and rely on FAA databases and inputs. In contrast, general aviation emissions are estimated top-down from national fuels data. Emissions of military aircraft are not developed by EPA. Commercial marine vessel emissions are included for both diesel and residual oil-fueled vessels. Port and underway vessel emissions are geolocated into shapefiles. This facilitates allocating the emissions to grids in multiple counties. And lastly, railroads. ERTAC created the 2008 Railway Inventory and incorporated many improvements. More information is contained in the classroom version of APTI 419B. It includes examples and case studies and more detail about allocation methods. Data sources and NEI methods are discussed in more detail. Note that recent improvements in Nonroad methodologies may not be reflected in the APTI 419B classroom version. Thank you for your interest in Nonroad emissions.